deviation of 8 yards. Okay? I'm going to start by drawing myself a little picture. So I've got Tiger and his drives. His mean was 304 and his standard deviation 8. 1, 2, 3 standard deviations above and below. So this will be 312, 320, 328. I'm just adding 8. And this will be 296, 288, and 280. Okay? That's what his distribution of his drives looks like. Make sense? All right, now, when we are applying this process to a real situation, in preparation for those of you that are going to AP Stats next year, we're going to talk about the minimum amount of work that needs to be shown to support your answer, so that when you have a question like this on your AP Statistics exam, you get it essentially correct, not partially correct. Okay? The readers of the AP exam, and I am one of them, the readers of the AP exam know that once you get your Z-score, you're either going to table A or you're using a tool on your calculator. So there's no work really that can be shown once you get your Z-score. So the work that you want to show to lead up to that Z-score is how did you get it? Okay, so how did you use your conversion formula to determine the value of that Z-score? Okay, so if you look at my first problem, first example with Tiger Woods, it says how far must Tiger hit his driver in order for the ball to travel a distance that would be at the 85th percentile? Well, given our empirical rule, could you tell me what the 84th percentile would be? Anybody? 312, because you know that if you go to one standard deviation above the mean in the standard normal distribution, you should have 84% that are below it. That's the 84th percentile. So we know the 85th percentile should just be above that a little bit, right? Okay. In this case, we aren't given the raw score. So we can't just go right to this formula and plug a number in for x. We got to find our z-score. How might, first of all, we recognize we're above the mean, right? How might I use table A differently, maybe, if I know the area below this z-score is 85%? What are your thoughts? What's that, Jimmy? I can't hear you. Okay, so Jimmy looked at 1.03. He has a 0.85, excuse me, that's below. And at 1.04, he's at 0.8508 below. Is 85% in between there? It is. So we can estimate that the that the z-score, that is at the 85th percentile is between 1.03 and 1.04. So we had to kind of work backwards, Tim, with our table. We gave you the area below, so you had to look in the body and then find the corresponding z-score. There's a faster way to do this on your calculator. So the other calculator command, I'm going to wait until next week to show you for finding area below. But this one is just too valuable not to show you today. If you are given a percentile, which is the same as an area below, to find a z-score, you can use a command that's called inverse norm. And you always give area below, which would be the same as a percentile. By the way, guys, I'm not giving you homework tonight. You're welcome. Okay, it's prom weekend, and this is a big lesson, so I'm being kind. So if we use all the time, I hope you don't mind. Okay? So in our case here, I want to do inverse norm, and the 85th percentile is the area below of 0.85, excuse me. Now, where you find that inverse norm command is in what's called the distribution menu. if you look at your VARS key, which stands for variables, you see above it in either yellow or blue, depending upon your calculator, district. Okay? Second VARS then will take you to the distribution menu. Okay? Everybody get there? Inverse norm is option 3. And like I said, you give area below, so 0.85, and this will give you a z-score. Okay? And Jimmy was right. It is between 1.03 and 1.04, isn't it? Okay? What's that, Jimmy? Okay, so I wrote it here in my notes. I'd write it down on your notes as well, just because this is new. You've not gone to this button probably ever before. Inverse norm of area below, you can find inverse norm under second variables, which is called the distribution menu. And when we did that, we got a z-score. It's actually closer to 1.04. You can use 1.036 if you want, but I'll round it to the nearest hundredth because table A does as well. Shane, can you help him, or Carter? Okay? And that makes sense because we know that the z-score of 1 is the 84th percentile. That means the z-score of 1.04 should be a little bit higher, right? Okay, so was everybody able to get that on their calculator? Okay. Okay, inverse norm, second VARS, inverse norm of 0.85.
And then I get
0
that.
and 1, yeah.
Oh, wait.
Yeah, do it on your home screen.
Hold on. There we go.
It should give you 1.036. Inverse norm. Yep, down the page.
And I get that.
There it is.
What the heck?
Everybody got it now? Jimmy, you got it? Yeah. Okay. Well, you can always use table A then, Jimmy. Okay? You can say, all right, is it closer to 1.03 or is it closer to 1.04? Well, 0.85 is closer to 1.04. Okay? So I'm just showing another tool because it's a little easier to use. Okay. Now we know our z-score is 1.04. So now we're going to, just like we used table A backwards, now we're going to use our z formula backwards. I'm going to put that in for my z-score, and I'm going to find x. I know the mean is 304. I know the standard deviation is 8. Yep, I got to use a little algebra. So I'm going to need to solve for x by multiplying both sides by 8. And then, somebody besides Jimmy? So you're Jimmy. Someone besides Jimmy plus what? Yeah. That gets rid of the minus 304. So if you take 8 times 1.04 plus 304, we know it should be between 312 and 320 yards, and it's actually 312.32 yards. Okay? So again, by drawing the curve, it helps you validate if your answer is reasonable. So the last thing I want to get here today, guys, is I want to write the things that are a requirement on a question like this so that we're preparing those of you going to AP Stats to get essentially correct scores as opposed to partially correct scores. Okay? Anytime you're dealing with a situation where you're working in the normal curve, okay? Step 1, find your z-score. Show your work. I demonstrated this on each of the first 2 examples that we did with Tiger Woods, or with the table A, excuse me. Okay. Then, once you have your z-score, then of course you're going to use some tool, whether it be table A or a calculator command, to find the area. Or if, like in this last example, we gave you the area, then we need you to find the raw score. using your z-score that you found in step 1. Okay? So what is a minimum requirement for essentially correct responses is to show your work in finding the z-score, even though it's simple arithmetic. Okay? All right. So given the things we've covered here so far today,